Today we're going to multiply, divide, and simplify radicals. Okay, so we're going to first simplify. We're going to show you some of the rules for simplifying radicals. Okay, then we could really multiply and divide, because multiplying and dividing is really simple. You just have to really simplify it afterwards. Does that make sense? Okay. So who remembers one of the rules for simplifying radicals? Yes, John.
Just that, like, if you have like a radical, then you can kind of like do the opposite of multiplying it, where you can break it down into more radicals.
Yeah, exactly.
Simplify the perfect square.
Perfect, very good. So the easiest way is if you have a square root of a perfect square, we know how to simplify that, don't we?
Yeah.
So something like this. So write this down. An expression having a square root radical is in simplest form when, first of all, no factors of radicand. Radicand is the number inside of the square root, right? No factors of radicand has a perfect square. Just like Jonathan says, if I have square root of a perfect square, you should, that's the easiest way to simplify. So that's the first rule. So write that down. And then there are two others that we're going to show you in a minute. And I'll do an example for this in a minute. So go ahead and write this down. So let's look at some examples. For example, square root of 8. Well, you may say, wait a minute. 8 is not a perfect square, but does this radicand 8 has a perfect square as its one of its factor? Yeah. Yes, it does. Brandon, how would it be? Yeah, this is going to be 2 rad 2, not 3, 2 rad 2, because this square root of 8 has a factor of 4, right? 4 times 2 is 8, right? So that's why we could write this as square root of 4 times square root of 2. What's the answer, Brandon, again? 2 rad 2, exactly. Do you guys understand what we're trying to say? This is something we already knew, right? So we have to make sure when you have a square root, to simplify square roots, the radicand, if the radicand has a factor of a perfect square, you gotta simplify that, right? We know how to write that. Simplify. We know how to simplify, right? The radicand with perfect squares as its factor. Any questions? All right, let me show you the second rule. Okay. No fractions are under a what? Make sure if you have a square root, let's see if you remember from last time. When you have square roots, you don't want the fractions. We want the fractions to have no what?
Okay, well, then after like you do the radical, then you rationalize the denominator.
Exactly, very good. You even know the name. So no fractions are under a radical sign. Okay, if you have a square root, in other words, on the denominator, that's not simplified. So for example, here. Okay, let me move this up a little bit. So I should write this down. So do we have radical on the denominator? It says no fractions are under a radical sign. So here, look at the denominator. The denominator is really square root of what? 4, right? Because remember the rule, square root of 3 over 4 is the same as square root of 3 over square root of 4. You guys remember that rule? So we cannot have square root of 4 on the denominator, correct? So in this case, it's nice to get rid of the square root because 4 is a perfect square. So what's square root of 4? 2. So that's easy, right? But are you always going to have perfect squares as a denominator? No. So what are you going to do if you don't? Well, we're going to do what Jonathan just said. Okay, so here's the third rule. And no radicals are in the denominator. So, for example, something like this. 2 square root of 3. Well, square root of 3, we don't know. 3 is not a perfect square, right? So we don't know how to simplify this. So how can I get rid of? So because the third rule is you don't want to have any radicals in the denominator. What can we do here, Sabrina? Good. You guys remember we did this before, and this is what Jonathan said. This is called rationalizing the denominator. Because right now, look at my denominator. It's an irrational number, isn't that right? So we want to make it into a rational number. How do you do that? Well, simply just multiply top and bottom by that denominator, square root of that denominator. Okay, so just that denominator which happens to have a square root. So when you do this, what does this become when you simplify? It simply becomes 2 rad 3 over, what's square root of 3 times square root of 3? 3. Now we have rationalized the denominator. Does that make sense? So this process is called rationalizing the denominator. Let me write that down. I already wrote it. Okay, there you go. So do you see why it's called rationalizing the denominator? Because our denominator was an irrational number. Now, by multiplying top and bottom by that denominator, right, it becomes a rational number. Does that make sense? Is that okay? You guys remember these rules? So there were 3 rules. That whenever you simplify radicals, right, first you got to make sure that the radicand doesn't have any factors of perfect square. If it does, you simplify. Second, you make sure, that there's no fractions. No fractions are under radicals if it's written like this. And then, basically, second and third step are kind of similar, right? You just have to make sure that the denominator, right, is not a irrational number, right? We don't want any square roots in the denominator. Does this make sense? Easy enough? So once you know these rules, these three rules, it's easy to multiply and divide radicals. Okay, so let's do some examples. Okay? So let's take a look at example 1. It says simplify 5 square root of 3 times 8 square root of 21. And so what should we do here? Well, it's pretty straightforward. All we have to do is, first of all, you got everything's multiplying. Right? 5 is multiplying square root of 3 times 8 times square root of 21. So could we rewrite it this way, where you just multiply the rational numbers and then multiply the irrational numbers together, right? 5 times 8 and times square root of 3 times square root of 21. And I highlighted square root of 21. Does anybody know why I did that? Okay, Ala, why do you think I highlighted square root of 21? It's not simplified, exactly. Is there a way to simplify square root of 21? Yeah, because 21 contains a perfect square as its factor, doesn't it? 21, when you do a factor tree, right, you will see, go ahead, everybody do a factor tree, you will see that 21 simplifies. I'll wait. Okay, everybody do this. So, when we do a factor tree for 21, how many people found out that it's really 3 times, oh, wait, we don't have a perfect square. I said it wrong, didn't I? Yeah. Okay, so, but, nevertheless, we actually want to do this. Why? Okay, sorry, I said it wrong. Yeah, 21 doesn't have a perfect square. What am I talking about? Yeah, okay, so it's 3 and 7. But, we want to do it this way because, Nicole, why? Yeah, because we have a square root of 3 here, right? So it's kind of nice to see, oh wait, even though square root of 21 doesn't contain a perfect square, I have another square root of 3. So we could simplify it this way. Does that make sense? So what is square root of 3 times square root of 3? 3. So don't you just get 40 times 3, which is 120? Square root of 7. How many people got 120 square root of 7? Do you get the idea? Okay, so sometimes you may want to separate these. Remember the rule? If I have square root of AB, it means square root of A times square root of B. Sometimes it's good to do this, even though it doesn't have a perfect square, because it may match up with the other one outside. Okay. Any question on example 1? All right, let's move on to. Is this pretty straightforward? Yeah. Okay, let's move on to example 2. Can you do something like this for your homework tonight? Because you're gonna have a bunch of these. All right, let's look at example 2. Okay, so before we do example 2, you guys remember this rule? If I have square root of A times square root of B, it's same as square root of AB. Okay, so this time we're gonna use that rule, I think. So take a look at this. Now we have 2 fractions multiplying, but they both happen to be happen to have radicals. Square root of 10 over 3 times square root of 27 over 32. So what should we do? Well, looking at this rule, what do you think we should do first before we do anything? Yeah, I see what you mean by cross cancel, but could we just write the whole thing inside a square root? Then what can you do with the numbers inside? You can now cancel things, right? Because you got a fraction times another fraction, you could simplify. You see what I mean? Do you see why I showed you this rule? Go ahead, everybody simplify and see if you could simplify this whole thing. Multiply. So we're multiplying 2 irrational numbers, right? I mean 2 radicals. Okay, go ahead, everybody try. I'll wait. All right, so when you simplify this fraction inside, what did you get? How about, let's see. Kira, what did you get when you simplify? What goes into, how can we simplify the fractions? Not the answer, but inside the square root, what does it become?
It's 5 over 1 times 9 over 16.
Good. Okay. So you see that 3 goes into 27 9 times, and 10 and 32, you could divide them by 2. So you get 5 over 1 times 9 over 16. Correct? Yeah. I could just actually write them separately. Square root of 5 times square root of 9 over square root of 16. Is that okay? Do you see this?
Yeah.
Do you see how things cancel out, right? 3 goes into 3 ones. 3 goes into 27 9 times, right? And then 2 goes into 10 5 times, 2 goes into 32 16 times. Right? Isn't that how we? Okay, so right, you can simplify divide top and bottom by, right? 2 and 5. I mean 2 and 3. So we get square root of 5 times square root of 9 over square root of 16. Of course, square root of 16 is simply 4. That's nice because 16 happens to be a perfect square, right? Easy enough? How many people got 3 rad 5 over 4? That's the answer. Are we okay? Yeah. Okay. May I move on to another example then? Okay. Is this pretty straightforward? Okay, if you didn't, go ahead and fix it now. I'll give you time. Okay, let's go on to the example 3. Take a look at example 3. Square root of 75 over 2 times square root of 18. Alright, what should we do in this sort of problem? Anybody have any idea? Should I rationalize the denominator right away? Not quite. Why not? Yes.
Because there's a rat thing at the bottom.
I know. So should I multiply top and bottom by square root of 18?
Yes.
You could do that, but that will not get you the simplest answer right away. What should you do first? Anybody see what to do? One person. Go ahead. 2. I want you to discuss with your team. What do you think? What should we do first? You could do that, but that's not the easiest way, simplest way. Okay, so some of you have some idea. How about Sabrina? What do you think we should do first before like multiplying top and bottom by square root of 18? What should we do?
First, you can simplify the rad.
Yeah, look at the square. Always do what? Always simplify as much as you can. Look at square root of 75. Do you think it's gonna have some factors of perfect squares? You know?
Yeah.
Yeah. What about square root of 18?
Yeah.
I think so too. So go ahead and do a factor tree for 75 and 18. And simplify those first, then rationalize the denominator. Okay, don't try to just rationalize the denominator from the top, because then you could do it. It's just you have to simplify a lot more. Then, okay, go ahead. Everybody try. I'll wait. So how many people did the factor tree for 75 and got something like this? I got 2 5s and 3, and then for 18, I got 3 times 3 times 2. Is that okay? Yes. Do you see how we have a perfect square of 5 here for 75? So did anybody do this? Square root of 5 squared times rad 3 over 2 times square root of 3 squared times rad 2. Right? And so what does this simplify to? James, what do we get? When you yeah, 5 rad 3 on the numerator, and then the bottom we get 2 times 3 times rad 2. Easy enough? Isn't that a lot simpler? So don't just try to rationalize the denominator from the very beginning. Always what? Always simplify. It's going to make your life a lot easier. So then when you do this, of course, you can multiply 2 times 3. You get 5 rad 3 over 6 rad 2. Am I done? Not quite. Why not? Angie, what do I do? What do I need to do? Why am I not done? Yeah, I need to multiply top and bottom by rad 2 to rationalize the denominator, right? We have a square root on the denominator. We don't want that, right? So you got to multiply top and bottom by rad 2. What's the answer when you do this then? Yes, Amy? Yeah, 5 rad 6 over 12. Okay. So, any question? Can I cancel out 6 and 12?
No.
No. Why not? Doesn't 6 go into 12 twice? Yeah, you can't do that. Why not? How about, anybody see why we can't? 2 people see it?
Oh, yeah, because
It's not 12?
yeah,
Yeah, rad 2 times rad 2 isn't that 2? So 6 times 2 is 12. So my question is, why can't I cancel out 6 and 12 here? Doesn't 6 go into 12 twice? Dominic, why can't I do that? Yeah, 6 is inside where? The square root. 6 is in the radicand, right? Square root of 6 is really 6. Right? Square root of 6 is some number that goes on, right? With some decimal that goes on forever. Where is 6, by the way? What's the value of 6? Where is it? Which 2 numbers is 6 between? Square root of 6 between?
5, 4, and
It's between? It's between 2 and 3, isn't that right? Remember? Like, here's number line, 2 and 3. Remember, 2 is really square root of 4. What's 3? Square root of 9. So square root of 6 is between here. It's going to be closer to square root of 4, right? Square root of 6 around here. Right? Does that make sense? So please don't think that you can cancel out 6 and 12. 6 is inside the square root. It's not really 6, is it? It's some number that goes on forever with decimals, right? Remember, irrational. Square root of 6 is an irrational number. Right? You guys remember this? All right. Okay, then if everybody try example 4. How do I multiply? Square root of 2 and 2/3 times square root of 1 and 1/4. We got some mixed numbers now. Do you think we need to change these mixed numbers to an improper fraction?
Yeah.
Go ahead, everybody do it. I'll wait. You should be able to simplify this expression. Okay, I'll wait. Did you all rewrite the mixed fractions as 8/3 times 5/4? I actually even wrote the whole thing inside the square root. Is that okay?
Yeah.
Why do you think I did that? Because look at 8 and 4. Can't you cancel those out? How many times does 4 go into 8? Twice. So always simplify, right? So we get this. So did you get square root of 10 over square root of 3?
Yeah.
What's then the next step? One person knows? Come on. Okay. How about, who haven't I called? How about Grace? What do I do here? What can I do? Yeah, you need to rationalize the denominator. So what do I do? How do I do that?
Multiply
Shh, Grace, what do we do? Yeah, multiply rad 3 to the numerator and the denominator. We could do that because what's rad 3 over rad 3 really?
3.
No, rad 3 over rad 3. Yeah, rad 3 over rad 3 is 1. So you're really multiplying 1 to the fraction, right? So it doesn't change the value, right?
Except for the 3 is not a radical. Not square root anymore.
Okay, yeah, so exactly. So when you multiply now, you get 3. I see what you mean. But what I'm saying is, how is it that we can multiply rad 3 over rad 3? Is that okay to do to a fraction? Can you multiply a fraction by same thing over same thing? Yeah, because this is 1, right? It doesn't change its value, does it? Okay, so we get square root of 30 over 3. Easy enough? Okay. Any questions? Now, so far, look at all the examples that we did today. Do you see any variables in them? No. Guess what we're going to have now? Okay, we're going to have some variables. Do you think it's going to change much? No, it's the same thing. Here we go. Okay, so it says multiply, and it says assume that all variables represent positive real numbers. And you're going to like this statement. Anybody see why right now? Why we like this statement? Oh, some of you see? Okay, let's just do it, and then maybe I'll ask one of you. Okay, so on your homework tonight, they're going to say this. Assume that all variables represent positive real numbers, and we like this. Okay, so very good. I think some of you have already the idea. Here, go ahead and multiply this. Now we have some variables. Now, instead of numbers, we have some variables. That's the only difference, okay? So it's the same exact thing we've been doing. Go ahead, everybody try. I'll wait, okay? Go ahead and simplify this, okay? So this is kind of easy because what's square root of a squared, guys? Yeah, what's square root of b squared? B. So could I just write it this way?
Yeah.
Now, don't I need the absolute value for a? Normally you do, but how come I don't really need it? You're right, I don't really need to put absolute value in this case. Why not? Okay, some of you saw. Stephanie, how come I don't need the absolute value? Yeah, because this statement. Assume that all variables represent positive. So you know that you don't have to worry about a being negative. Does that make sense? But if I didn't say it, do you see why I would need the absolute value? How come I don't need the absolute value for b then? Even if this statement wasn't there. Dominic? Yeah, there's a b inside a square root, right? So we know b can't be negative because otherwise it's undefined, right? It's not on a number. It's not a real number. So you're right. So we just have to say 12ab rad b. Okay? Is that okay? Easy enough? How many people got this answer? Okay, do you like this statement now? This statement is nice, right? You don't have to worry about putting absolute values when they say this. But if they don't, you have to put it. So if they didn't put that statement, this will be your answer. Okay? It's not that bad, right? It's not that hard. Anyway, okay, good. Example 6. Let's take a look at this example. We have square root of x times square root of x minus 3. Do you guys remember how to multiply a binomial with a an expression outside? Go ahead, everybody try. I'll wait. This is pretty straightforward, isn't that right? So did you all remember to distribute this square root of x like this? Yeah? What did you get, Tegan? Okay, go ahead and finish. Tell me what you get. We'll wait. So when you distribute the square root of x, you get? Uh-huh. 3x? Yes. 3 rad x, right? Okay, give me a sec. Am I done? No. What is square root of x squared, guys? Look, x squared is a perfect square, right, of x. So isn't this simply x minus 3 rad x? Any questions? Can you do something like this for your homework tonight? Good. Have a good day.